All right, we're at section C now, which is the multiple angle or double angle. We're going to focus in on double angle for the most part. We've used fundamental identities. We spent time with cofunctions and sum and difference identities. That's what we did in the last two sessions. And now we've arrived here. We're going to use multiple angle identities. What does that mean? Well, this would be theta, and multiples of theta, what would those be? 2 theta, 3 theta, sure. Before we go into it, I want to go back to something which we've talked about before, and that's the law of additivity. Very few functions obey this law, that the function f of u plus the function f of u will equal the function f of u plus v. We looked at a couple that clearly don't follow that. Square root, squaring, neither one of them follow it. And we also looked at some of the trig functions. So, what about doubling? If we were to double a trig expression, will this be equivalent to taking the value of double the angle? So I've got a couple true and false for us to look at. The first one, we're just going to use our mental calculator. We can figure out what the tangent of 30 degrees is, can't we? And we can figure the tangent of 60. So 30 degrees, this one will be a 30 degree. And then we'll have 60 degrees. This will be our 60 degree. We really could use just one triangle and just look at it with a different orientation, but I'm drawing them both. So we've got 1 and 2 for the hypotenuse, 1 for the short side, 2 for the hypotenuse, and the square root of 3 for the long leg. Okay, so using our mental calculator, what's the tangent of 30 degrees? It's y over x. Okay, so there it is right there. Plus the same thing again. Now, is that equal to the tangent of 60 degrees? Let's look at tangent of 60 degrees. Tangent of 60 degrees is the square root of 3 over 1. All right, are those equivalent? Well, 1 over the square root of 3 plus 1 over the square root of 3 is 2 over the square root of 3. There's no way that that's equal to the square root of 3. Agree with me? So, I mean, you could prove it to yourself by doing it on your calculator. The square root of 3, we have a pretty good idea what that is, right? 1.7, something like that. And the reciprocal of that, well, just to totally clarify this, let's look at 2 divided by the square root of 3 and see if it's anywhere near 1.7. No, not really. Okay. Well, so that turns out to be false. false. It is not true. How about tripling? 3 theta, okay? Cosine 3 theta, does that equal 3 times cosine theta? This time we're going to use, instead of a mental calculator, a metal calculator. Well, metal and plastic, yes. Okay. So we're going to do some graphing. Y equals, we'll put in one side. And you remember that if these are equal, when I graph y equals 3x, and then I graph y equals 3 times cosine x, they'll look identical. So let me put in cosine x for the first one, and then, oh, no, go back up. Cosine 3x for one side of the equation, and then I'll try graphing 3 cosine x. Now we say if these are actually equivalent, then the graph of this side and the graph of this side should look exactly the same. Our window will be, we'll do it in radians. Let me make sure we're in radian mode. We are. So we'll do our window negative 2 pi. Here's our angle measure going up. You know what I did? I know what I did. Some things I never learn. Okay, window. So I should have used this negative. Negative 2 pi. And then 2 pi. And then we'll use pi divided by 2 for our tick marks. And then we'll go negative. Notice I'm using the correct negative. I do learn, at least in the short term. Nothing wrong with my short-term memory. Okay, so now we're going to graph, and we'll see what we get. There's the first one. There's the second. Of course those aren't the same. Remember what we learned about amplitude? The amplitude on this one is 1. See that? The amplitude on this one is 3. Ooh! Up and down. Up 3, down 3. The other thing that we sure know is frequency. This one is going to cycle 3 times in 2 pi. This one is going to cycle 1 time in 2 pi. See, 1 time in 2 pi. There's another 2 pi. Well, this one goes 3 times in 2 pi. Another 3 times. All right. So this one, this statement here is false. These are not equivalent. So tripling doesn't work. Doubling doesn't work. You can't just use this law of additivity. All right. So what can we do? We're going to prove the double angle identity. You'll see all the double angle identities right here. We've got the sine of double theta. Cosine of double theta is pretty interesting. You actually get 3 identities. You get your choice. So if you happen to know both cosine theta and sine theta, I'd use this one. But if I only know one of them, then I am going to have to use either this one or this one. Tangent double theta. There's what we use. Okay, so we're going to try to prove this one, this very first one. Is there anything we already know that we could use for this? So we're going to work with this side. And instead of having alpha and beta, two different angles, we're just going to say theta and theta. So what if they're identical to one another? It still should follow this rule, right? So we write it out. And, of course, that is equal to, remember this is the commutative law applies with multiplication. So I could write this as sine theta cosine theta plus sine theta cosine theta, which is the same as 2 sine theta cosine theta. So there's a proof of the double angle identity using the sum identity. Let's find the value of 2 theta cosine 2 theta and tangent 2 theta when we know what sine theta is and cosine theta is. All right. So what am I going to use for 2 theta? I only have one choice anyway. I have to know, in order to find sine of double theta, I have to know what sine of single theta is and what sine cosine is. Well, good. I do know what they are. Here's sine of single theta. Here's cosine of single theta. It's going to be sine of 2 theta. Sine of 2 theta is going to be equal to 2 times the sine of single theta times the cosine of single theta Now remember, when we've got fractions, we multiply together the denominators and we multiply together the numerators. So I end up with 5 times 2 is 10 times 12 is 120. And 13 times 13. Okay, so now let's reveal that. That's exactly what we had. Nice. And then we'll do cosine of double theta. And I'm lucky. I have cosine and sine of single theta, so I can use any one of these. When I've got them both, I can use any one. I'll start with that first one. Okay, here's a little challenge for you. Can you spot the goof? It's coming up. So it's going to be cosine 5 over 13. This is my single theta, and I'm going to square it, plus sine of single theta squared and that's going to equal 25 over 169 plus 144 over 169, which will equal When I add those up, what do I get? (169 over 169). Really? Wow. I don't think so. I must have done something wrong. One of the things we didn't check up here, and we should have, is what quadrant we would be in. If these are both positive, we know we're in the first quadrant with our single angle, but that doesn't necessarily mean we'll be still in the first quadrant with... Oh, I see what I did. You see it? Stupid. This is not an add. No. I knew that couldn't be it, but I didn't see my mistake. My mistake is we are subtracting here, aren't we? Whew! There. Okay. Now it's starting to make more sense. If I subtract 144 from 25, I'm going to have a negative answer. So 144 subtract 25, 9, 119. So I have a negative 119. Woo! I knew it was supposed to be negative over 169. Yes. All right. Oof. That was a close call. All right. You have to use the identity as it's written, not invent something. Because what I invented up here, it was not true. What did I use? I actually used the Pythagorean identity, which would be always equal to 1. Well, at least I proved that for you again. Now the tangent of 2 theta I need to know what the tangent of single theta is, and I don't have it. Although, how could I do this? I could say, okay, I know that I could do it this way. Sine of double angle over cosine of double angle would do it for me. So actually, really, I think I rarely will be using this one. I could, because I can figure out what tangent of theta is. I know this is my y, 12, and this is my x, 5, so my tangent of theta has to be I have these long pauses waiting to hear from you and have to remind myself that I can't hear you. Probably talking to me and I can't even hear you. So we could proceed with this, but I think this is usually easier, so let's go this way. You'll see why I like it in a minute. Sine of double theta is 120 over 169, and cosine of double theta is negative 119 over 169. So that will simplify to 120 over 119, and the sign of that will be negative. So we figured all three of them. Yes! Oh, wow. Yeah, we might have a misstep along the way once in a while. But what do we do as we go through problems? We ask ourselves, does it make sense? And if, like in this one, it was going to be equal to 1, I'm saying that doesn't make a whole lot of sense. Number 2, we're going to find the same thing again, but look at our information. This time we start out knowing what the cotangent is. And what else do we know? We know that sine is less than 0. So cotangent is positive, so that would say we could be either here or here. And sine is negative. Well, where is sine negative? Sine is positive here and here, so it's negative here and here. So we are in quadrant 3. I want to know what, I either want to know what tangent theta is, or sine theta, or cosine theta. I need to know one of those in order to even get started. Well, since I usually, there's something about sine that always attracts me to it, so let's figure out what sine is. If x is equal to 5, we know that, right? Because cotangent theta is x over y, and y is equal to 12, then r must be equal to, where this is a right triangle, we have our lovely, lovely Mr. Pythagoras, who did some work for us years ago, so we could figure out that that's 13. 25 plus 144 equals 169. The square root of 169 is 13. So from that I can get sine of theta. Remember, this is my single angle stuff. Sine of theta equals 12 over 13, but it's in my third quadrant, so it's negative. My cosine of theta is going to be 5 over 13, but it's in the third quadrant, so that one also has to be negative. Those are the two I like to have, if I can, those are the two I like to have when I start into these double angles. So now my sine of double theta is going to be 2 times the sine of single theta times cosine single theta. So I'm going to have a negative 12 over 13 times a negative 5 over 13. So this is going to be equal to, seems like we did this calculation recently, right up here, didn't we? Yeah, the only difference is this time I have negative and negative. However, if you multiply two negatives together, that's right, it's positive. So we've got the same answer we had in the earlier problem, 169. Now that's kind of interesting, isn't it? to know that our single angle has us in the third quadrant, and then our double angle has us, we actually don't know, right? But we're either here or here. In a moment we will know, won't we? Once we know what the other three are, we'll know what quadrant we're in with a double angle. Let's find out. Cosine 2 theta is equal to, we're going to square this one. Well, we start with cosine. This is subtraction. Subtraction. We square cosine. So minus 5 over 12 squared. And then we're going to do minus, then we do the sine of single theta, minus 12 over, oh, I like it when I catch my goof early. That's supposed to be 13. So what is that all equal to? When we square a negative, it becomes positive, right? 169. And this will be 144. Oh my goodness, this looks pretty familiar. Over 169. We've been here already. That's a 9. You know that. That looks just like what we did up here, doesn't it? Alright, so it's a negative 119 over 169 for this one. Gee, with so much going on, I don't know why I'm not boxing. If you don't box, it's hard to find the answer. And then for tangent of 2 theta, I'm going to go the easy way. Instead of using this identity, I'm going to take the sine of 2 theta over the cosine of 2 theta. They have the same denominator, so I know it's going to turn out to look like this. It's going to be negative because one of these is positive and the other one's negative. And it's going to be 120 over 169. So which quadrant are we in with double theta? Cosine is negative. Sine is, well, let me change pen colors here. Sine is positive. Cosine is negative. Cosine is positive here and here. It's negative here and here. And tangent is negative. Tangent is positive here and here, so it's negative here and here. This is where we are. We're in quadrant 2 with our double angle. Double angle was in that quadrant, and single angle, single theta, was in that quadrant. Makes sense that when you double it, it's going to jump to a different quadrant, doesn't it? I think we're going to break this one right now. I'll let you take some time this evening to work on example 1 and 2. See what you can do with those. I am going to pick those up in the next video. So do your best with it when you come into class tomorrow. And then tomorrow night, it'll be fairly easy for you.